Welcome to the art of measuring. Let's look at this line that we need to measure. We're using a centimeter ruler. Each of these numbers represents centimeters. So I think we can probably say this line is at least 7 centimeters long. Now notice it's past the 0.5 mark. So we can say, it's at least 7.5 centimeters in length. It's the next part. That's the uncertain digit. I'm going to say that measurement is 0.08 centimeters. You might say it's 0.07 centimeters, or perhaps 0.09 centimeters. That last digit is the uncertain digit. It's what you decide is the best measurement. If the measurement is 7.58, the first two digits are exact, and the third one has a slight error to it. Significant figures are extremely important when reporting a numerical value. When you make a measurement in class, you should be thinking about how many decimal places should you include on that measurement. The number of significant figures used indicates the confidence or certainty of that value. Let's look at the centimeter ruler again. What is the smallest increment on the ruler? By increment, I mean graduations between the smallest lines. You might say 1 millimeter. You might say 0.1 centimeter. Those are equivalent amounts. They're both right. What is the best guess you can make within that increment? That best guess is about 1/10 of your smallest increment. So if your smallest increment was 1 millimeter, your best guess is to 1/10 of a millimeter. If your smallest increment was 1/10 of a centimeter, your smallest increment will be to 1/100th of a centimeter. If you're using a centimeter ruler, you should be reporting your value to 1 decimal place if you're reporting it in millimeters, and you're reporting it to 2 decimal places if you're using centimeters. Let's look at a meter stick. What's the smallest increment on the meter stick? What's your best guess for a measurement? This is the halfway point on the meter stick, so this is 50 centimeters. The smallest increment is just like the centimeter ruler. It's 1 millimeter or 0.1 centimeters. Your best guess will be 0.1 millimeters or 0.01 centimeters. When using a meter stick, your measurements should be recorded to 1 decimal place when in millimeters and to 2 decimal places when using centimeters. We use vernier calipers in class. To use vernier calipers, well, first let's look at the main parts of it. We use it for precisely measuring the length or width of an item. We're usually using these lower jaws. You could also measure the inside of, say, a cylinder or a pipe. Or you could be using the stem to measure the depth of, say, a hollow cylinder. This is called the main scale. The vernier scale is this lower part. The screw clamp allows the jaws to remain in place while you make the measurement. Let me show you how to read a vernier caliper. So, the jaws have been placed around an object and the screw has been tightened, and now we're ready to make a measurement. Notice that the 0 mark is past the 1. So in this illustration, that represents 10 millimeters. You're looking for the 0 mark going past the main number. Now you also could have read this as 1 centimeter. The next digit in this illustration is looking at where that 0 is. Notice it's past the 6 millimeter mark. Now remember, they've already used 10 millimeters, and now they're looking at the 6 millimeters. I usually just go straight out and read 16 millimeters. The next part is where we use the vernier scale. Again, that's this lower part. Notice this tells us the division here is 0.05 millimeters. Look at the scale and how the graduations on the vernier scale are lined up with the graduations on the main scale. Notice the zeros off a little bit. We're going to keep going along till I see one that's lined up. That 2.5 is nice and straight below the other measurement. We don't care what the measurement value is on the main scale. We're reading the vernier scale. So this gives us the decimal point, which is 0.25. Here's just their indication of 0.25. When we put it all together, we have the 10, we have the 6, and we have the 0.25 off the vernier scale. Add those all together and you get your measurement of 16.25. Again, I usually just directly read 16 in that first step and then read the decimal value for my measurement. There's no other digits that you add when you use the vernier scale. Use this first example to practice a reading. Be sure to write down what you think it is before you check. We'll see if this works. And here's another example. For more practice, cut and paste this website in your browser, or address in your browser. You'll have a vernier caliper that looks like this, so a little different than the ones illustrated. These bottom numbers represent 1/10 of a millimeter. And practice a little bit, see what you think. The next item we're going to look at is a micrometer. We use this for measuring spheres. So you want to place the sphere so its diameter is lined up in the anvil and the spindle. The sleeve has our main measurement, and then our decimal value will be derived from the thimble. The ratchet is used once you put your sphere in here. Tighten down the ratchet to hold it in place. Don't tighten it so tight that you're making indentations on whatever object you're using. Let me give you an example of reading this. So you have some sort of item between the thimble and anvil. Notice the sleeve is past, this is a 5 millimeter mark, that's a 6 millimeter mark, and a 7 millimeter mark. These lower ones are 0.5s. Notice that your sleeve hasn't quite reached a 0.5 part. So the measurement on this is 5, 6, 7, 0.35, 36, 37, 38. So 7.38. And these are millimeters. You will not be adding any digits to this reading because the graduations are so fine, you won't be making any guesses. You can practice reading a micrometer at this website, so cut and paste it into your browser. And tomorrow in class, we'll be practicing the art of measuring. You'll get to use all these instruments.